All right. What do you guys want?
I have a few questions.
I have a few answers.
Okay, so, well, the first one is, do you know how many points Moodle's out of right now? Like, the points of, like, overall?
Yes. 920, as long as that's assuming that your fourth lecture and lab exam are added in, which they should be, I think, for you because I have you
Yeah.
in lab.
Okay. And then this might be...
Hold on 1 second before you go on. For some of you, right, that I don't have tests from Hobbs and Perry, right, as long as you know those scores, then you could add those to whatever you see on Moodle and then divide by 920 to figure out what you have. But the only thing left that I have from you guys to be graded is the 150-point exam. Okay?
Sweet.
Cool. All right. Go ahead, Grace.
And then, will there be any, like, diagrams or, like...
There will not be. It's all multiple choice and matching, which I still consider multiple choice because you have multiple choices. That's it.
Okay. Thank you. That's all I have.
Wait, how many points did you say it was out of? 900 and what?
Well, the class is 1,070 points. Right now, we have 920 points accounted for, so you have 150 points left for the final. Does that math add up? Anna, is that right?
Yeah, I'm pretty sure it's right. I'm grading like the last 3 tests right now, so.
Oh, yeah, that's right. Anna had a couple left, which is fine. And no rush there. You're still in your time frame.
Yeah, but there's 2 more, so I figured I could just.
Yeah, get those done.
Do it.
Stop talking.
But yeah, I'm pretty sure right now Moodle's got 920 points in it, and the classes.
Right. And it might show up again. It sometimes because of extra credit stuff and weird stuff, it shows up weird. So ignore like whatever the total it's telling you if it's not 920, because I'm telling you, once Anna, once she gets these last couple done, for a few of you, even though I think all of you have your other ones done now, everything else done, it's out of 920 points, right? So whatever the point total is that Moodle says you've earned, that's correct. And then you divide that by 920 to figure out what your percentage is. Okay?
Have you dropped all of the like lowest quiz grades? Did you already like drop those?
Yeah, it does that automatically.
Okay.
So the score that it's telling you for your quizzes, that is taking your best 10 into account.
Okay, thank you.
Don't and some people don't believe me, and I'm not saying you're one of those people, but you can go through if you want to double check it, by all means, and add up your 10 best. But it should be doing that automatically for you. That's why I have it set up.
Okay, thank you.
For mine, it says that like quiz 12 isn't in yet, and it's dropped.
Yeah, and that's true. I have to go and actually, because I have to do that manually because it was just an essay.
Oh, okay.
Yeah, but I'm gonna leave yours out anyway, just for bothering me. Okay.
Okay, that's good.
Yeah, so I'll go back and I'll do that, so you can. I assume that should boost some of your grades slightly, right? If you have a 0 on one of your quizzes that it's counting, then it'll shoot that up by 10, type of thing. For everybody, that'll probably boost it slightly, maybe only a few points, but some of you maybe a few more. So, good call, Grace.
Thank you.
Yeah, you're welcome. All right, anybody else? Any studying questions or? I'm fine if it's all format issues.
Did you say that we're going to be taking our
exam at like that 1 to 3 time slot and we have to be on Zoom? Like, I don't remember.
Yes. Hey, Emmeline. So yes, my plan is that it will be done during the regular final time. And understand, even if you were meeting in class, sometimes there are legit circumstances that students have. And so if you have a very legitimate circumstance, you can reach out to me and I can make, other arrangements. But the plan is for the majority of you, we'll do it during the regular time. So I'll sign on and be on just like we are in class regularly. And that way, if you have any questions or concerns, or if you notice a question's off, because I can't remember who it was on Zoom, maybe 2 exams ago, pointed out, hey, like the choices weren't right on this question because I had left all of the above, and you know how it kind of randomizes them for you guys. And so that I was able to know about that and then kind of adjust. So yes, please sign on, Zoom on, and then we'll just go from there.
Okay, thank you.
You're welcome.
The tests are done.
The tests are done.
Mm-hmm.
All right, so now you should be able to see your point totals if you have me for lab and lecture. I still need scores from Perry and Hobbs, but I'll jump on that today. But I think most of those are available to you guys even on their site, so you can kind of do the quick math yourself if you need to. But divide all the points you have, divide by 920 right now. All right.
Do you know how many questions the final will be?
I
was just curious.
Yeah. I can look right now. Give you an estimate. Final. Let's see. So it looks like it's probably going to be, I'm guessing 75 questions.
Okay, thank you.
I think I'm going to do each question worth 2 points is kind of my plan. Yep, 75 questions. It could be 85 potentially because I might make some of them just 1 point. So between 75 and 85, but more than likely 85 or 70. More than likely 75. Sorry.
Okay, thank you.
Mm-hmm. Anybody else? Please, I said in the email, don't forget there's that study guide there to kind of help you out. All right. Anna, do you have anything you'd like to add?
I don't know. The only questions that I've gotten in email form so far have been just about grading and whether or not there will be 1 grade for all of A and P.
Yeah, someone actually emailed me that too. Yeah, guys, so in case there's any confusion, right? Like your lecture points, your lab points, they all get put into the same pot, right? And what you'll get is a letter grade based on that. And so as long as your letter grade is a passing grade with all of those things added together, then you just get a P for the lab. So if you notice on your schedules, the lab is actually 0 credit and the lecture is 4 credits. But the reason lecture is 4 credits is because it has all the lab stuff added to it. So you get 1 grade for everything combined. And then as long as your grade's okay for the combined, then you just get an automatic P for the lab. And please remember, because this is primarily a nursing class, that anything below a C by the School of Nursing is going to be considered an F. And in that case, what I would recommend is if you fall below a C, and you see that on your grade, right, then you have the opportunity to request a W and a chance to retake it without it affecting your GPA. All right, but the nursing school is not going to accept a P that is the equivalent of a D. So just keep that in mind. And again, if we need to discuss kind of your best options, you can email me, but you don't make that decision until you see the grade that I've entered in. All right. I mean, we can talk about it ahead of time, but that request for that W or for that P is not made until grades are finalized. Okay. So just wanted to let you know that that's in play, or to remind you of that. Anyone else?
I did want to ask, what were some topics that were most commonly missed on the last exam? I know it's like really generalized, like everyone could have struggled on different things, but I was just wondering, just so we
Yeah.
could focus on
You know, so for the most part, here, let me pull one up. I'll just do here. I can look quick and just kind of see. I think overall the matching was really good. The multiple choice was relatively good. I can scan through because it gives me these averages. Okay. Question. Oh. Back here, question 6. Where? I have no idea.
Okay, I'm sorry. Still
Hey, I'm on.
Oh,
Yeah, I'm in my class.
I'm sorry.
That's okay.
Is this your?
This is my A&P. Yeah. So, you know, I would look up the, so one of the questions, have neuro commonly found in the ganglions outside the CNS, right? That was supposed to be unipolar. That's one that was frequently missed. That's like I think, well, here, I'll scan through. I think it's a multiple choice question that was most frequently missed. Other than that, they were all relatively good. What's this one? Surprisingly, ion channels that are opened after an impulse, right? So an impulse is going to cause, right? An impulse means that there's been a change in charge. And so that's going to be voltage gated, not chemically gated. All right, so I'd say that was about, I mean, a lot of people got it right. A lot of people got that one wrong. Let's see, what's this one? Got that one. So, I mean, where I hit you guys a little hard were some of the essays. And so, you know, the kind of the shorter essays where you had the myelinated axons, explain how an impulse moves down a myelinated axon. A lot of you guys left out the fact that in the nodes of Ranvier, right, those unmyelinated sections, you have voltage gated channels, right, that are responding to that impulse that are allowing sodium to run in. A lot of people still mention that the signal skips or jumps, right, and it doesn't skip or jump. Those myelinated sections are electric insulators, right, that allow the impulse to move through without having to open gated channels. So it appears that it is skipping or jumping, but it's moving all the way through continuously. All right, so that's kind of a big one. Surprisingly, when I asked about the 3 reflex arcs, right, patellar, withdrawal, and crossed extensor, a number of you got those right, but a number of people were saying, we'll say some interesting things that were not correct. So maybe reviewing those would be good. Short-term memory, you guys actually did really well as a class on that, those of you that chose to answer that. And then, you know, the last essay question, which was, why is the resting memory potential of a neuron negative 70 millivolts? Also explain how a threshold potential is reached. These were all over the place, right? So what I was looking for, and if you actually go back and click on your exam, you can see that I left comments in some of your exams. But when we talk about, you know, the resting membrane potential, and some of you guys did a good job, right? But you have your sodium potassium pump that's pumping sodium out, potassium in. You have that going on. You also have a bit of a leak though, right? So sodium's leaking back in, potassium's leaking back out, potassium leaks back out at a higher rate. So you're losing more positive charge there. But then the really important thing, right, is that besides the sodium potassium pump and the leaking of those ions, you also have sulfate and phosphate, which are negatively charged ions that are trapped inside the cell, right? They can't get out. And so it's those things all interplaying or working together that gives you that negative 70 millivolt resting membrane potential. All right. For a threshold potential to be reached, right? Maddie, what happens before a threshold potential is reached?
Depolarization, a local potential change.
Right, a local potential change. And how does that depolarization happen though?
Oh, the sodium gated channels open. The sodium rushes in, causing a positive
How do the
charge.
sodium gated channels open?
Oh, that probably would be helpful to know. I don't remember.
Right. And so, you know, so if you go back, right, you have a stimulus, and you know that's nice if you said, but before any, right, you have a stimulus that hits a chemically gated channel that opens. So sodium rushes in, just like you said. You then have a depolarization event, and if you have enough of a depolarization, you then open the voltage gated channels, right?
So when you say stimulus, like, would that
That would be it.
be
Oh, go ahead.
neurotransmitter
Right. So
or
you'd have a neurotransmitter, like, so you could take acetylcholine, or you could even say norepinephrine is one of the other ones that we kind of talked about. So norepinephrine, right, binds to a chemically gated channel. It opens it, sodium rushes in, and if you have enough channels being stimulated, and that's kind of what you were alluding to, enough sodium rushing in, then you hit that threshold potential. And
there was a question on the review questions that you put in that one Word document at the very beginning of the year. And it was saying something about calcium 2 stimulating get some channels to open. I'd have to look it up. But what is the deal with calcium 2? Because that was really confusing for me.
calcium, I mean, that'd be taking this even a step farther back than I would want you guys. Calcium is important for allowing, if we're talking about neurons, for allowing a neurotransmitter to be released. So if you go back,
Yes, that's right. Yeah, you're right. Because that's what it says. Yeah.
And so, I mean, a lot of you guys, you know, did mention depolarization. But again, you know, this was a 10-point question, and I felt like we spent a lot of time kind of on this overarching kind of, here's a resting neuron. What are all the different things that are happening to it? What are the different things, you know, that are moving? So, you know, on a whole, and again, you know, different things for different people. Some people maybe miss a little more multiple choice than others. That's fine. But on a whole, I would say as a class, most of the points were lost because the explanation of a signal moving down a myelinated axon was missing a good amount of detail, or there were things added in that shouldn't have been added in. the 3 different types of reflex arcs. Some of you got them but didn't describe them correctly. You didn't talk about like afferent, efferent interneurons at all, which is important when we're talking about the physiology of it. Like I said, some of you talked about very different things. And so between those kind of 2 questions and then this essay is where a good chunk of points were missing. And some people did really well and some people maybe not as well. But I'd say overall those were kind of the 2 big ones, neuronal signaling.
I was wondering, sorry, I was wondering if you could just briefly touch on the reflex arcs, because I know that in my study time, the 3 you said I didn't focus on, so I probably did lose points on that question, but regardless, I would like to.
Right, so remember, your patellar reflex arc, also called monosynaptic, right, is the simplest reflex arc. And so it's going to have, here I can actually, why don't I just pull this up so you guys can see it. AMP1. Okay. Working lectures. Just 4. All right. So here's kind of a brief rundown here. All right. So if you're going here, we're talking about patellar. And you can see that it's a monosynaptic, meaning there's only one synapse. So it has your sensory or afferent neuron, right, that is stimulated. And then, right, you have your efferent exit effector neuron that then sends a signal. In this case, it flexes the muscle, right, which would cause the knee to be pulled up, right? Which you then go to your withdrawal. And here what we see, it's a little more complex because you have your afferent or your sensory. You then have an interneuron, right, that is a connection point between the afferent and the efferent, okay, causing a muscle contraction where you pull your leg up, but, right, not to occur separately from the crossed extensor. And here you can see that there's communication with both sides of the body. So here's your sensory or afferent neuron, right? It connects to an interneuron. This interneuron causes a response, right, on the side of the body, in this case where the pain is being experienced. So you have these muscles contract. That interneuron also allows communication with the other side of the body, right, where it then connects to efferent neurons that, in this case, we're talking about stepping on a tack, right, cause the contraction of muscles on the contralateral, right, opposite side of the body that allow stabilization, all right? And so I wasn't, looking for anything deep, but this idea of afferent, efferent, and then interneurons allowing these reflex arcs to take place and operate. All right, and some people were pulling in, which is fine to pull them in, but we're just talking about tracks during their answers, which is not necessarily getting on the 3 types of reflex arcs. Does that help a little bit, Maddie?
Yes, that actually helps a lot. I did notice though, when I tried to access the PowerPoint, I don't know if you can do anything about this even, but the little bottom part where you have those extra notes, it wasn't allowing me to scroll. I can try it again, but
Try again. I don't think I have, as long as it's a PowerPoint, it should have notes on there. Potential. I mean, the only thing I'm thinking is, if I've added notes while I was preparing for a lecture, but you should have access to any notes that I have on those uploaded ones. So maybe double check again, right? And if there's something I need to provide clarification for, I can I can definitely do that if you're looking for something else. Okay,
Yes, that helped a lot though. Thank you.
good. Anybody else? Yeah. Hannah, Bailey, Catherine, Olivia, Riley, Lauren, Jordan, Noel, Grace, Maddie. Any more?
Yeah, sorry.
It's okay. Lay it on me.
So I know that in the muscle chapter we talked about the sodium potassium pump, but then also in this chapter it talked about that, and I was just wondering what the correlation or difference is, or if there even is one.
Okay, so I mean, that's a good question. So in both situations, right? They are setting up a gradient, right? And so, actually, you know what we can do? I'll go back to chapter 11. Okay. Yeah. Okay. Let me share this again. I know I want to do chapter 10. There we go. I'll show chapter 10, and I'll kind of use this to try to explain both. We'll see if it works. I hope it doesn't confuse you more. I don't think it will. No, not that. Ugh. Zoom and I are fighting. There we go. All right. So if you remember, here. All right. So I think this is actually a really good slide. Okay. So sodium potassium pump, whether you're talking about a muscle or a neuron, is getting a lot of sodium on the inside. I'm sorry, a lot of sodium on the outside. Sorry, a lot of sodium on the outside and a lot of potassium on the inside. All right. And so in the case of both a muscle and a neuron, these membranes, for the most part, right, are impermeable. So that means that the sodium, once you pump all of it out, it can't just come back in easily, and that potassium can't just go back out easily. All right. So you're causing a big collection. So they're basically, they're kind of not, they're pushed up against the door, right? You have a lot of sodium trying to get in, you have a lot of potassium trying to get out, but they can't cross the membrane. Okay. So in the case of a muscle, what happens, right, when acetylcholine binds to its receptor, it actually makes that membrane permeable. So you just open every single kind of door, essentially, right? And so sodium rushes in, potassium rushes out. And when those positively charged ions, right, cross paths, that's what creates the impulse, right? You have positive charges moving both directions at the same time, and that's what actually creates the impulse in a muscle cell, okay? For a neuron, what you've done, right, is you've done the same thing, a bunch of sodium on the outside, a bunch of potassium on the inside. But now it's not the membrane we're affecting, it's actually channels that we're opening. And so, right, when you have that chemically gated channel that opens, well, sodium rushes in because you've put a lot of it on the outside, right, which causes depolarization. Now, in an axon, all of that potassium that you've put on the inside, right, is important because you're going to open potassium channels that allow repolarization after the sodium has rushed in. So it's the same in a sense for muscles and neurons because you're making these gradients. You're putting a bunch of sodium potassium on one side of the membrane so that when you open something up, whether that be the membrane or whether that be channels, those ions are going to want to rush in or rush out. Does that kind of help or make sense?
Yes. Yeah, it does.
Okay.
I had a question about on chapter 11,
Mhm.
like the basal nuclei and the diencephalon. Like I
Okay.
just don't even know like where to start. Like I'm just so confused about all of that. Like,
All of it, huh?
well, not like all of it, but just like the diencephalon. I know it's like made up of like thalamus, hypothalamus, and stuff like. But I'm not exactly sure like why it's important. And like the basal nuclei, I know it's in the limbic system, but it's like
Okay.
I don't know what the basal nuclei does.
Okay, so let me pull that up so I can look at it. All right. So here I can show you my notes. The big thing, right, with the basal nuclei that's kind of cool or interesting about them um, is if you look at the brain, right? This is I'll pull this. Not gonna let me. There we go. If you look at the brain, right, the brain primarily is gray matter on the outside, right? So this is where you have the cell body of a lot of those multipolar neurons that are important for processing information that they receive from sensory and then sending it back out via effector signals. And the inside is white matter, right? So this is the myelinated axons, right, that belong to the cell bodies or belong to the cell bodies of neurons that are farther down in the central nervous system. And what's cool about the basal nuclei is they are actually groups or collections of cell bodies within the white matter. So they're actually kind of little sections of gray matter that are embedded within the brain, all right? And one of the things I have here, right, is that these are actually important for producing dopamine, right, which is really important. You see here for motor control. And so the basal nuclei, um, if you know someone that has like Parkinson's, actually start to degenerate and they aren't producing as much dopamine. And so that's one of the things that causes the clinical symptoms that are associated with Parkinson's, right? So that's kind of their main thing, right, that they're doing, right? It's this release of dopamine, just for motor control, which is important for voluntary movement. So if you've seen someone with Parkinson's, right, they have a lot of those tremors, and they lose the ability to control a lot of their body.
Yeah, I think like one of the reasons why I got confused because I saw like the ganglia and I thought that was like outside the central nervous system as like little mini brains, but like
Right.
like a group of.
So you do have a couple. So you have dorsal root ganglia, right, which are the ones that we typically are talking about. But the basal nuclei are a type of ganglia because they are a collection of cell bodies, right, that essentially are out of place. Does that make sense?
Oh, okay. Okay.
See, the cell bodies in the brain should kind of be here, but we actually have a collection here. And so in that way, they are very similar to the ganglia that we talk about in the spine, right? So, one way to think of ganglia is it's kind of outside of the location that you would expect, right? So those dorsal root ganglia are a collection outside of the spinal cord. These basal nuclei are ganglia. They're a collection, right? It's still in the brain, right? But it's not in the same area. Is that helpful?
Yeah, no, that makes sense. That makes total, yeah. Okay.
And then, okay, so you're talking about the diencephalon, right? Is that your next thing?
Mm-hmm.
So my big things, for the diencephalon are not that all of this, doesn't matter, but you already kind of know about the pituitary a little bit, and you also know about the pineal gland a little bit. Total crazy side note: my wife and I were watching Are You Smarter Than a Fifth Grader, and there was the contestant on there she was a dentist, right? So she had a lot of anatomy and physiology. And the question that would have won her $50,000 was what gland produces the hormone melatonin? And she said the pituitary gland. And so she lost $50,000 and only got 2,500 instead. I was actually yelling at her on the TV. So remember, this could definitely matter for your job, and it also might matter if you're on a random trivia show. So please know it. But for as far as the diencephalon, two of the things that I'm really interested in, right, are the thalamus and the hypothalamus. They're kind of major components in it that we hadn't really talked about. Well, I guess we've mentioned them kind of on and off, right? But just knowing about them. So hypothalamus, when you think of anything homeostasis related, right? And specifically, the hypothalamus is going to be able to sense when you move away from equilibrium within your body, right? When you move away from that set point. And so it can generate the responses that start the negative feedback loop. The thalamus, right? Remember, is kind of like that gateway that is allowing communication, right? With the cortex, all right, to kind of all regions of the body, right? So it's kind of like one of those crossroad areas. And then we specifically did talk about the limbic system, right, which includes, right, the hypothalamus, right, and the thalamus as the diencephalon. Also has some stuff in the basal nuclei in there, along with the temporal and frontal lobes. And so the diencephalon is an important kind of part of that. So that's kind of all I'm expecting you to know is what's it made up of, and then really the hypothalamus is kind of the big one, just because this ties in a lot of different things that we've learned throughout the semester, and things that you'll actually talk about even more in AP2.
Okay.
Yeah, we didn't really delve too deep into it. So basically, what are the parts of it, and kind of what are the thalamus and hypothalamus doing? And then you can see that diencephalon contributes to the limbic system. And I do like, and we did mention this throughout this unit again, the limbic system is a great example of all these different parts of the central nervous system working together to generate these different kind of feelings or responses. So good question. Is that kind of enough to at least have you?
Oh yeah, that was enough. Yeah, that's what I was. Yeah, it was good.
Okay, good. What else? I got some more time. 20 more minutes of it exactly. And we could talk even after that. I just have another Zoom meeting. Anybody else?
I knew on the test it had something about like a red blood-brain barrier. And I know that it's red because it's vasculated, but besides that, like I think I got that one wrong, and so I was wondering, like,
Blood-brain barrier.
yeah,
Well, so there's
like what about
blood.
it? Like,
There's the blood-brain barrier. Is that what you're talking about?
yeah.
So blood-brain barrier, right, being formed by, do you remember what type of neuroglia?
Is it the astrocytes?
Yeah.
Okay. Is that like all we really need to know about the like? Cause I think I remember like astrocytes connect in the central nervous system like to blood vessels and stuff.
They help form vascularization. They form the blood-brain, or important part of the blood-brain barrier, just kind of making an impermeable layer right to the brain, because you don't want things to be able to easily get in that could cause inflammation.
Okay.
So I can't remember
yeah.
the question you're asking, but that would be, if I'm asking about the blood-brain barrier, if I'm asking about astrocytes, it would be pertaining to that kind of concept.
Okay, yeah. I definitely could have worded that better. Like I didn't really know what I was asking myself, but no, that's kind of, it got answered.
Okay, good. And so if you decide later that it wasn't answered, email me and we can figure out the right answer if that's not exactly what you're trying to ask. Anybody else? All right. Well, if there is something else and you're not asking me, which I have a feeling could be Maddie, please email me and let me know, and I would love to talk to you guys either via email, or if we had to, we can totally work out a time to Zoom between now and then if you think of something else. All right? Okay. Well, get out of here. Use that study guide. Prepare well. And I will see you guys on Zoom.